And now we go to our next topic. And next topic will be a workshop prepared by Andrei Enshin. So welcome, Andrei. Once you're ready, let's start our workshop.
Yep. I work at Rakuten. In my free time, I play with Radare2. It's the same as GDB, but a little bit different. Today I'm going to show how you can solve one of the tasks from past CTF challenge. Actually, it's available right now. You can open the link and you can see tasks from this CTF. This is what we solved, and this one I will show you. Actually, link I shared in chat. So this is challenge of category town, and you can download binaries from left and right at marks, or you can use lab. It's just a server. You can SSH with root access. This is a password, and use Radare here because probably you don't want to install it from scratch. Maybe I need to put somewhere. So you need to download the program and libc, the program compiled with, because libc might be different from your system one. Let's check information of our binary. There is a command rabin with a flag I information and provide your binary elf file. I left on the screen only important parts. The most important is peak is set to false. It means that position independent code is false. It means that code always will be loaded at this address. So we can predict the code address. Also, we can see that our architecture is x86, 64 bits. It's for Linux, and the interpreter is set to this one. Later we will change it. So PIC stands for Position Independent Code. You can read more on Wikipedia. As I said, program code always will be loaded at this address. So let's check version of libc. I didn't know, but actually you can run libc. I thought it's just library, but actually you can run it. When you run it, you will see output. libc will tell you its version. That's only what it can do as a binary. The competition libc has 2.31, but my system one has 227, so they are not compatible. And that's why I had some difficulties during solving this challenge. And I will show you how you can solve it, how you can bypass. First of all, you can use this libc from challenge and run your program, but it will crash. Do you know why? Any suggestions? Does someone know why? Evgeny, maybe you know, because you kind of C developer. So when you use LD preload, so you can use custom libc with a binary which actually was compiled with it, but it crashes. The answer is, but when you run it as this, it works. So different libc crash, why? The answer is because there is a different linker used. As I said a few slides before, in ELF header it calls interpreter. They call it interpreter. So it's dynamic linker which used, it also must be compatible with this libc. So we already have libc of another version, but we don't have linker, and we need to patch our binary. Actually, as a side note, sometimes LD preload is enough when the change is not so big. Maybe I'm wrong. This is my observation. So, but I will show you how to patch it, and it actually works. It actually solves the issue. So let's see again. Our interpreter set to this system1, right? So when you run your program, this guy, LD Linux, will load it into memory, it will patch your binary, and that's the root cause of our issue. We will put, actually we need to download this libc deb package. Unpack it is just a usual archive. Unpack it second time, and then you will find this one loader which you really need. And then just patch. There is a patch elf command with set interpreter, and you can set your interpreter on your var.ma binary. So very easy to do. After that, you can see that your interpreter has different paths. It's relative, not absolute as it was before, and proper version. So finally we can run binary. So it's the very first step, just to run binary. We even didn't start debugging and anything. So I put some name, Goga, and binary said me that I hope you find yourself too, and just exit. Let's do some fuzzing. Actually not fuzzing, but I put 123 bytes of A to this binary, and it crashes. So seems to be some buffer overflow. Very easy. Before trying to debug it in Radare, we need to prepare profile. Using profile for Radare, you can set std out, std in, and you can preload libc. We already patched our binary, so we don't need to do anything else. This is enough. For std out, you can just use second terminal. Command TTI will tell you the device ID, and then you can sleep infinitely to not to use it only for this purpose. Also, we can, for input file, we need to also provide some input. You can use this Debugging sequence using rag command. It will generate sequence like this: A, B, A, C, and blah, blah, blah. I will use sequence of length 123 bytes. So now we can run in Radare, providing this profile. D is for debug our binary. So it's loaded. Using command DCU, it's debug continue until main. So we can execute until main. And we hit breakpoint here. And then we enter visual mode by V. You will see such screen. This is main function. It's very small function, and there is something wrong inside this function. What is wrong? Let's see. Oh, it uses some bad function, gets. No one should use it. Even in man, you can see that never use this function because it's vulnerable. This function doesn't check boundaries of your buffer. It will write to buffer as many bytes as user provided. So very simple. Currently we stopped at main. We need to continue execution until gets. To do it, enter to command mode. It's like a Vim based, just colon. And then you can run command dcr, debug, continue until ret. Ret is return. So now we at ret at the very, very end of our main function. And what we can see at stack, we can see that our stack is filled with this sequence. So RSP points to poison stack, and stack has our data. So we can control stack. All right. We want to know how many bytes should we put until this address D08, because the ret will use this address, whatever data we put here, to return. So we want to know how many bytes we should put before, and then our whatever you want. There is a command in Radare, VOPO, I don't know for what it stands for, but you just copy whatever you find in your stack to this command, and it will tell you 72 bytes. Okay, let's generate a 72 byte sequence and then put some random 4 bytes. Rerun our program. OD is reloads program. DCU main, again we go until main, and then DCR run until ret. So you can combine all commands in one line. And finally, we can see in our stack our value. So we can put anything. So we are here. By the way, Radare has documentation. You can append question mark, and you will read documentation for each command. For OOD, for DCR, for DCU. So we do control stack. What's next? Next, we'll do ROP. What is ROP? ROP is return-oriented programming. We will do it in its basic form, of course. There is a good video in YouTube from Overflow something channel. I highly recommend you to watch it with explanation, or read just Wikipedia. If we have time, we can watch it. Live Overflow, I think most of you know about this channel. So he explains how some unexpected things about ROP. How to go back. Let's move on. Let me try to explain by my words why it's return oriented, because each ret instruction will go wherever we want, since we control stack. So we control stack, we can put address, return will bring us to this address. Why programming? Because by such small jumps, we can run whatever we want. So we can call these gadgets, we call them gadgets. Gadget is a sequence of instructions with a ret at the end. So there might be any instructions which you find useful in your binary, or libc also binary. Let me show you. There is a command in Radare, slash or backslash, I always confuse them, R. It says search for ROP gadgets, and you can see some ROP gadgets. ROP gadgets look like this. It's just instructions, pop, for example, pop R12, pop R13, pop R14, and it must end in ret. So everything which ends in ret we consider as a gadget. So using these gadgets you can build your program, whatever you want. You can write any code using these blocks. So this is return-oriented programming. That's what we're gonna do right now. So we can decide our plan. Libc address, maybe a little bit not clear why we need to do it, but every time you run your program, libc address will be different, because there is ASLR. Then we need to calculate libc base. It's easy to do, and then we can turn our program around to read input once more, to run get gain, and supply one gadget. One gadget is a sequence of instructions which give you shell immediately. So instructions like exec v bin sh. So actually there are 3 gadgets in libc. You can see on my screenshot. There is a program written in Ruby which parses your libc or whatever you supply and gives you one gadget. We have 3 of them. Actually, they are almost the same address with a small, it is the same gadget but with different constraints. And one gadget has some constraints. It means that when you run this gadget, you have to, your registers, for example, R10 must be null, or address which is stored in R10 must point to null, and R12 must be the same. I'm going to choose third one because it's easy to meet. This one, RSI and RDX, because RDX actually will be 0 at this point. I need to deal only with RSI. How to leak libc address? So the target program, which we're going to debug, calls functions from libc, such as printf. So there must be clue between program and libc. Libc loaded at random address, our program loaded at the fixed address. So how our program knows about it. There is a mechanism which is called relocations. I don't know how it works. Somehow it works. Final result will be inside memory of your process, of your target program. There will be written real libc address, which is random. But if you read this part of memory of your process, you will get this address. How it looks like? It looks like here. Relocation section, printf, has address in reverse, but you can read it. So this is a stack address. It's not an instruction. Radar will interpret it as in some strange instruction, but actually it is address. So we can, and this address is fixed. So we can read libc address by relog printf address. Hard to explain, but I think you got the idea. So what we're gonna do? We're gonna call puts supply address. This is 404030 in RDI register to puts and call. So puts will read whatever on this address and print. It will interpret it as null terminated string. So it will print everything until it will meet null. Good for us. How to do it? How can we put in RDI target desired value? Just use such gadget. There is a command which I showed, rq. You can ask to filter for gadgets, pop RDI, and it will give you gadget. At this address, there is exactly what we want. Pop RDI and return. Let's use it. So our stack will look like, instead of kek, it will be pop RDI, relog printf, address of relog printf, address of instruction which calls puts. So we need to put three piece of 8 bytes. So pops RDI, pop RDI pops relog printf in RDI, and then ret will bring us to puts. Let's see how it will be. So we already know all the 3 components. We know where is pop RDI, we just found it. We know where is relog puts, and we know how to call puts or printf. You can call printf or puts. I decided to use relog puts instead of printf just because I did so during actual solving. But to be honest, I tried setbuff at the beginning. I failed because setbuff offset has 0, 0, and puts cannot print everything. So we will use puts. Also, the address which I use to call puts is not real call of puts. So call of puts has located on this address 40128D, but we cannot call it directly. We cannot go to this address because there will be leave instruction, and leave instruction will mess our stack. So if we go to next after call instruction, if you kind of go inside this puts, you will see 1, 2, 3 instructions which jump you to relog puts, and relog puts you already know it will be address of libc. So we will call this guy. This guy will not have leave. It will have somewhere deep in libc. It will have ret return. And what we need ret because we're doing return oriented programming. So what we've done so far, we patched our binary to run custom libc, we found vulnerability, it's not so hard to find. We decided plan with one gadget. Now let's move on and try to get real libc address. I'll use pound tools to write exploit. So here is pound tools. I think some of you already heard about it. It's just Python binary. Let's go line by line. There is for debugging, to preload libc I use just env. Then I open input file because I want to use this input file in Radare in future. I start process with this environment variable, and also I do load libc because I can find puts offset from this libc. Then the process which we opened, I can read whatever the process prints. So when I print out some data, I can read it until question mark. Then the same sequence, debridging sequence, you can do in pound tools. There is a cyclic, 72 bytes. Then our popper di, relog puts and call puts. Then I send it. I read only 6 bytes. I append a few zeros. I transform it to 64 bits and I print it here. Let's see how it will work. So just run it, Python test solution, and you will see what we sent, and you will see what we get. We've got the libc address, and you can check in Radare. It will be the same in your case. If you don't use ASLR, if you use ASLR, it will be always random. In my script, as I said, I write the same output to input because I want to input file. I want to use this input file in Radare. About ASLR, a few words. It's address space layout randomization. That's why we need to leak libc. But this will not stop us because we can leak it. So let's try to input what we know. We know already libc base because we just leaked it. Plus, if you plus to this base one gadget offset, you will get shell. But how can we supply once more? This solution is jumped again to the main function. So when we leaked libc, we still control our stack. We still can jump whatever to any place in our program. And we want to jump again to the main, to the beginning of this main function, because it will read again our input, and we can supply already known address of one gadget because it's random. So we read it, we supply it, and that's our plan. So let's run the Python script with pound tools to generate input file. And then let's go into Radare with this input file and debug step by step. When we do it, we can realize that our program is going to call exit. But why? You can see there is an object counter, and it must be 0, otherwise it will call exit or move on. Actually, it will increment it. So the program has kind of unexpected check. You can see here, if you can see my screen. So here is a counter object which located on this address, at this address, and we test. It will be moved to X, then it will be test. Less or equal, we will go here. But otherwise, we will go to exit. So there is kind of protection from puts, but I don't think it will help. So what should we do? It's nothing impossible for ROP coders. We will continue writing our ROP chain. we can simply rewrite this counter and jump to main next. So before jumping to main, we want to rewrite this counter because it's already incremented to 1. How to do it? Gets, we will use gets function, which will read our input and store it to the counter variable. Counter variable is a global variable, so we already know this address. As I said, as I showed you, this is, so we can, oops, not pspx. So we can see that actually it's 0 right now, but if we execute until DCU until here and print it out again, oh, it's already, okay, because incrementing is happening here. So we, after incrementing, it's still 0. Okay, it's moved back. Now it's moved back. So counter is 1 right now. And this is address of counter, 6C. You can see in my PX, 6C. So we want to rewrite the counter. Then we will supply just 0 and new line. So gets will read it and will rewrite. Okay. As I explained, we can jump to gets. Actually, not to gets, but to, as I showed you before, to this trampoline. They call it trampoline. To trampoline to reloc gets. As I explained, yeah, I don't know why I put it again here. Because there is a leave instruction and we don't want to leave. Actually, there is a documentation what leave instruction does. Leave instruction will rewind your frame pointer. Frame pointer, it means EBP. EBP is kind of function frame. When you call a function, you will move your stack a little bit and you will use it for local variables. So leave will kind of undo it. We don't want to undo because we already have our op chain in our stack. So run Python again to generate input. You will see what we supply, a lot of addresses. You can cut your input and verify that it's what we expect, or it looks like what we expect. And then run again to Radare, go again to Radare, reload it and DCU until main. Then use DCR, it's until return, run until return, or press SS as I showed you on my screen. When you press S, it's just a step, one step. If you press big step, it's step out, or you can step in, but we don't want to step in. So, and then, after coming back to main, we can see that our counter actually is 0. So we successfully did override counter. So finally, we are in main with zeroed counter and with knowledge of real libc base address. Let's run this here until the red and get general protection exception somewhere in printf call. Why? Why we got exception somewhere inside libc, not in our program, but somewhere in libc. If you look at this instruction, move ups stands for move aligned packed single precision floating point values. The important part is aligned. Here is documentation. The main part, it must be aligned to 16 byte, 32 byte, or 64 bytes. Otherwise, there will be stack. The value must be aligned. So let's check. Our stack address is you can there prints register, and you can specify any register. I specified RSP. stack pointer. Our stack pointer is this one, just before exception, and you can get, how to say in English, a static reminder. You can get reminder of dividing on 16, 8. On 32 it will be 24, on 64 it will be 56. So we can confirm that our stack is not aligned because we put in our stack some rope gadgets, addresses of rope gadgets, and we didn't control it. We just put whatever we want. But it's easy to align. You just +8 and you will see that everything will be aligned if you make it +8. So we need to find some dummy gadget which will do nothing, but it will kind of consume 8 bytes of your stack. So you can use again search for gadgets. I found some gadget which harmless. It just add DH to H. Nope. This is instruction almost nothing and red. So how our exploit looks like. This is for stack alignment, just gadget, and then we rewrite our gets counter. Nothing visible. And then we jump back to main. So this is how it looks like. So run Python to generate input file, reload program in Radare, and make sure you can reach return second time in main. Then we can supply one gadget. So if you remember, our one gadget has two constraints. RSI must be null, RDX must be null, or address which is stored in RSI RDX must point to null. Let's look closer at RSI and RDX being a threat just before calling one gadget. RDX is okay, but RSI is not okay. It has some value which points to not 0. Itself it's not 0 and it points not to 0. What should we do? Yes, we should keep roping. We should find another gadget which will change our RSI. Pop RSI, then pop R15. We don't need it, but we cannot find better. So we will do it. We will make RSI 0. By the way, R15 we will make also 0. And when we run it again, we've got bonus constraint. What does it mean? It means that my RBP is messed with some dirty things, and when we run this instruction, it actually failed, it crashed because there is no such address. And one gadget doesn't tell me about it, because probably there is expectation that RBP will be correct. But in my case, it's not correct. So we need to do it once more. We need to find a gadget which will rewrite RBP. We already know some valid address. I will put my global variable of counter here. So this is counter, this is gadget address, pop RBP. And finally, our exploit is ready. Just don't forget to put interactive on your process to be able to input something after getting shell. So this is final version. So this is your first input. Then you rewrite your counter, and then you make RSI 0. Then this make RBP to be correct, and one gadget. Yep, when you run it on your local, you will get a shell, so I can cut flag and I can receive some dummy flag. Or you can actually run, instead of process, you can run remote and connect to anything. It's like netcat, but you will you can send data, you can read data in Python. So you can connect to this challenge and receive real actual flag. Everything works. So this is how it works. Thank you for listening, and I'd like to. Oops, segmentation failed. It was a joke. I can do it on my screen to make it more clear. I'm not sure someone followed it, so probably you just listened. But let's do it on screen. Is it possible? Do you see my screen, or maybe this is better? Let's do it. Just a second. So here, if you connect to remote lab, you will get the program where I am, and you will get the libc, which will show you just a version. LDD. This is system libc. You'll check it. So system libc has 27 and current one 32. So it's not compatible. Let's check. Oh, sorry. LD preload. Where I am, so it crashes. So we cannot run it with this libc with preload, but with system libc we can. So it means that loader is not good. So then we will patch elf. Patch elf with we will use this command. I need to download. So I need to download libc. Then I need to extract it. And it must be around this folder. Yes, we have correct linker. And then we will just patch it. So we patched. Let's check with Rabin. Grep interpreter. So yeah, our interpreter is here. So actually you can put whatever you want. You can put like blah blah blah, and then obviously your where I am will never run with strange error, no such file or directory. I don't know why it's saying like this, but now it's better, but we need still to use reload the libc which supplied, and now it will work. So with patched interpreter everything worked with any custom libc. Let's move on, and what we will do, we'll get our profile. Std out, I will not use std in, will be this one. Profile is ready. Yeah, I will not use it. Rug, let's do it. This is interesting thing. Actually, I discovered this part when I was preparing to workshop. Before I used Pound tools for this. I didn't know that Radar can generate the sequence. R2 profile and debug where I am. DCU main. Now we at main, and let me ask. I don't remember bits. Not bits. Just a second. It must be maybe bytes, not bits, but bytes. Yeah, just don't need this. So let's DCR until return. We are at red, and now we can see our stack. Oh, screen is not good. So here is our stack. Here, RSP. You can see the stack points here, and at this point, at our RSP, we can this yaza, and with command wop. Just a sec. PX. Better, yeah, I need to take it from here exactly. So it says 72 bytes before this string. We know it. Let's put 72 bytes to input. And then echo whatever, one cuckoo. DCU main, DCR, and if we go here, we can see that cuckoo exactly at this point just before it. So if we press next, we will try to jump to cuckoo, but there is no such address. It's not valid one. So, okay, let's move on. Rope. So we need to find our first gadget, RQPopRDI. Go to main. We can find, actually, you can see all gadgets in your binary. There are a lot. You can search by any. So we have this address. Yeah, I think then I just want to copy paste. So I think everyone is bored with this, and that's probably it. Yeah, I will not go. Deeper because it will take some time. Yeah, if you have questions, and I see nobody is following. If you have questions, please ask. Yeah. Where is our translation?
So, Andrei, thanks for presentation, and I have one question. So you basically using pieces of libc and probably also like pieces of initial ELF file to search for red gadgets. Yeah. So basically, you need those pieces of code to be somewhere. Yeah.
Yeah.
So can it happen when because of any constraints or any reasons you just can't find gadget that you actually need?
Yes. Yes.
So it's possible. Yeah. In that case, you just can't exploit program.
Yeah. If you don't have gadgets which you need, then yeah. You can think how to say. Yeah, most likely there will be no. If there is only way to exploit a program, you need to supply specific gadget, and you don't have the specific gadget. Yes, you cannot do anything else.
I ask you because you mentioned that you can develop almost everything, but it's like assembly by itself, Turing, of course, full language, but rope gadgets can be not Turing full, so you can develop like everything. Yeah, you can just
actually they are. If you have few simple gadgets like I don't know what do you need to be full Turing? You just need few instructions to be able to do it.
Yeah,
Then,
well.
then you can build a gigantic rock
Yeah, but
gadget, which
this is for this model application, right? So in this case, for example, distance between actual input and corruption of stack is very short, so you cannot like somewhere deeply inside the application. Yeah, there's not too much transformation happens with input, so it can be not so easy in real application. I mean, like crackme obviously is a very simple application, so it's much easier to develop.
Yeah,
and exploit.
I don't know about real applications. I just solving crackmes. I never seen how real exploits. Yeah, it's a good question. We need to check.
Okay, yeah, I'm also curious. Is it only one technique that can be used to prevent these attacks, like ASLR? Maybe something else also exists.
There are many, but canaries is for another thing. Canaries, yes, for stack corruption. For example, when you overwrite a lot of things and before read, actually, good question, because this binary has no, I think has no canaries. Otherwise, we will have problems. Canaries. Yeah, it's false. Otherwise,
yeah, you can write some limited amount of data to stack, and after that,
you cannot do anything, by the way, because canary check usually located before it. It's located here. Must be. If there is a canary, if there were a canary, the libc will inject code before you read, and code will be like call, and function name will be check canary. So it will check canary. If it fail, it will exit.
yeah, okay, thank
so
you.
you cannot do anything with, but there are techniques to brute force canary. There are techniques to steal canary, so you can steal it, and then you can supply it, and your rope chain. There are a lot of techniques.
Okay, thank you.
Okay, any other questions?
Yep, no more questions.
Yeah, we actually our next speaker is already ready to present. So thank you, Andrei.
Yep, thank you.